Well, greetings to you friends. Here's hoping you followed the training step by step up to this point and have had no issues, and you've reached this point and you can do the mechanics as well. Or you may be a mechanic yourself and want to start the training directly from here. However, my suggestion is following the training from the start. It may take you a whole month longer, but you will learn the program much better because there are a lot of important topics that we've discussed in the previous training videos. And I say this once again, in order to follow the training in this phase, you need to be somewhat familiar with the application in the MEP part, because we're not actually teaching the Revit MEP itself. And another point is that you need to know some technical mechanical expressions, or if you haven't studied mechanics yourself, you need to ask these from someone who actually is. You need to link up with them in the first couple of works to learn the expressions. Although the application and the modeling itself is one thing, and the technical aspect is a whole other thing. If you're actually following the training, it's best to have both at this point. So it's best to be a mechanic yourself, unless you're working in a company where a mechanic is available for your questions and inquiries. Because the beam itself is a teamwork, and it's best that each person focuses on their own discipline, because there are a lot of issues that are actually engineering related, and only a mechanic could identify them and figure out the ways to solve these issues. So now we have the mechanical plan in the AutoCAD file here, and as you can see, we have the order and categories of the detailing of the plan. However, you should note that there is no plan without a fault, and this plan does have a lot of faults itself. We'll try to start the modeling phase and then we'll deal with the issues. If we're actually thinking about this as a project simulator, we would have ran into a lot of problems if we didn't use this method. And you'll realize how helpful the beam method actually is. So here, as you can see, we have the sewage, and then we have the water, the fire, that's actually about thermal resistance. Then we have the cooling. Next to that, we have the heating, and then the exhaust, and the rest follow as such. We basically have everything that would be used in an actual building to learn this process thoroughly. So right now we're going to start the process, and imagine that you're starting at the level 0. If you remember, we gave you some instructions in the BP itself, like how the plan should definitely be a CD file, and be absolutely sure to tell the company to stamp their CDs. Now it could be the company itself or the contractor, but we need something to show that the file that you're receiving is something approved. So after you receive the file, we'll start the checking process. So according to my own experience, there are some scenarios in the checking situation. The first one of which is you deal with it in a simple manner. So you'll need to prioritize these, and this should be stated in your BP. For example, in the mechanic phase, we model based on priority. Now, this priority may be based on execution or the complexity of the modeling itself. And if you want to state the priorities of the mechanical phase, the sewage has the highest priority, and the sewage and the water should be done first. The reasoning of which is sewage has a slope. As an example, I'll show you the mechanical file here, and you can see the structure next to it as well. So let me just go here now and select the wall that we have on this side, and we need to see this area. So let me just make a section box over here so we can actually take a thorough look at the area to see what is actually going on. Alright, so when it loads up, you'll see that we have some shafts over here, which may actually bother you in the 3D view. And as I've already stated, you can go to the visibility graphics menu and find the shafts over here and uncheck its box, and then they won't be highlighted in the 3D view. So Let me just pull this a bit closer. All right, so rotate this and then open this up. All right, and pull this open. Let me just increase its depth so we can get a better look at it from this angle as well. All right. Let me just increase it just a little bit more. And if we could actually find the space where the bathroom goes, it would be much more helpful. All right, so just take this as an example. We'll go over to the visibility graphics options. I think I've already made a filter for these. So select the structural floor through the menu and then OK. Then I'll uncheck its box so that after we've done the structural phase of this floor, we won't have to see it and we'll just get a better look. So a point that we've already stated in the previous sections is that we never complete the suspended ceiling before completing the mechanical aspect. We may create a flat ceiling based on the height that was set in the architectural plan, but we won't give it any details. We'll leave the details for after the mechanical code has been done. So as I was saying, we'll prioritize the sewage and the water, and we can actually do them in one step. An important reason why we do the sewage first may be that when you're actually doing the sewage itself, you'll bring these about for like 50 or 60 centimeters down. And then this has to move in the direction. So let me just go over here in the AutoCAD file and then go upstairs to show you the direction. For example, here we have a line right here and it says the rest is done in the ground floor. So this line goes from here and then through here, and it has to move with a 1% slope. The code that you see under the ceiling may be around 50 centimeters. And if it moves with a 1% slope, it may get to 60 centimeters. So this is moving with a slope, and we may not have collisions any earlier, but we will have some the higher that we go. So because of this, we complete the sewage first, and then we'll freeze it and leave it to the side so it won't be touched anymore. And so you have to check in with a team or the contractor or the counselor that you have to close the sewage in the first step. And when you're done with that, you won't touch the sewage anymore. And then the team may deal with it in the execution phase later on. So as we said, the first step is to complete the sewage and the water itself and the drain pipes because they are moving with a slope, and then the fire insulation and the canal, and we usually do the cooling and the heating water last because they don't have any limits in the pathways of their pipes and no collisions either. You can easily move the pathways around and change them. But if you were to do the same for the sewage, it would cause a lot of problems. And because it's moving with a slope, changing its direction may cause collision with a number of things. So you'll sort out the priority in the BP for your team or for your contractor, and you'll tell them that we're going to do the work in this order. So now we'll imagine that we've received the planning, and before we get to the modeling, we need to check the plan itself. So there are a couple of ways to go about this checking. The first one of which is doing a simple eye test in which you move around the plan and try to figure it out.